Hey guys, welcome. Yeah, so this here is Euler's criterion for the Legendre symbol, and I promised 3 videos on it. In the video I already made, we introduced it and looked at some very basic examples. And in this video, we're going to look at slightly harder examples and expose its limitations. And in a video to follow this, I'll prove it and so show where it came from. Now, in the introduction video, we looked at some very basic examples and we're in familiar territory. We've been working in Mod 7 for the previous videos, so we already knew that 2 over 7 had to equal 1, and it was easy enough arithmetic to check using Euler's criterion that 2 over 7 is 1. And then we checked that 3 over 7 was negative 1, which was equally easy. But what about if we wanted to know what 2 over 23 is? That is, if we wanted to know whether or not 2 is a quadratic residue mod 23. How would we go about that? Well, can Euler's criterion help? Let's see. So here, A is clearly 2 and P is 23. So the right-hand side here would say that we have 2 to the power of 23 minus 1 divided by 2, so that's 2 to the 11, and it's mod 23, right? Okay, cool. Now, 2 to the 11 is not too bad of an arithmetic problem, right? So we've got like 2 to the 5 times 2 to the 6, and 2 to the 5 is 32, so we've got 32 times 64, and we can do that as like 30 plus 2 times 60 plus 4. And so now that's 30 times 60 is 1800 plus 30 times 4 is 120, and then plus 2 times 60 is another 120, and then plus 8 at the end. So that's 1800 plus 100 plus 100, that makes 2000, and then I left out 220, so that's a 40, and then an 8, so that's 2048, right? Okay, cool. So we see that this is equal to 2048 mod 23. And now all you have left to do is reduce mod 23, which amounts to dividing 2048 by 23 and looking at your remainder. Now, I'm not going to do that by hand, so I'm going to pull up a calculator, and we're going to do it using a calculator. So on this calculator, if we did, and so you can check with me, 2048 divided by 23, it's that. So we want to subtract the whole number part, which is 89, and multiply by 23 to look at our remainder, and it is 1. So basically what we just saw is if you reduce mod 23, 2048 is equal to 1 mod 23. Poor writing, sorry. 1 mod 23. And so what this means is, first, that 2048 is 1 more than a multiple of 23, right? And moreover that because 2 over 23, the Legendre symbol, is equal to 1, we see that 2 is a quadratic residue mod 23. Yeah? Okay, cool. So you see, like, we picked a relatively big P, and we're still good. We're still in safe territory. And so let's look at a slightly different example. And so this time, pick a slightly bigger A as well. And this example is 5 divided by, or 5 over 13. Is Euler's criterion going to help with this? Well, let's see. We know that 5 over 13 is going to have to be congruent to 5 to the power of 13 minus 1 divided by 2. 13 minus 1 is, what's 13 minus 1 is 12 divided by 2 is 6. So that's 5 to the 6 mod 13, right? Mod 13. But 5 to the 6 is the same as 5 to the third times 5 to the third. This is equal to 5 to the 6th, right? And 5 to the third is 125. So we have 125 times 125. That's the task at hand. And we can, like we did earlier, right? 100 plus 25, and this might be even easier, 100 plus 25, and then do it out this way, right? So this is going to equal, well, 100 times 100 is that many zeros, right? 4 zeros, yes. And then plus we'll have 2500, right? A comma there. And then we'll have another 2500, comma there. And then we'll have 625. And so these guys combine to 5,000. We've got 10,000, so that's 15,000. 15,625. Got it. So we've got that this is the same as, well, now I don't have to say congruent, I can say equal, because we're comparing this to what I'm about to write. It's equal to it, which is it's equal to 15,625 mod 13. And at this stage, you can divide 15,625 by 13 and look at your remainder. As I did earlier, I'm going to use a calculator, and so the calculator will say that 15,625 divided by 13 has a decimal part. So if we again take the whole number part, which is 1201, and multiply the decimal part by 13, what do we get? We should get 12. Okay, so that says that we can reduce 15,625 into 12 mod 13, but as we know, 12 is the same as -1 mod 13, and so we see that this here is equal to -1, and therefore 5 is not a quadratic residue mod 13. So you can square all the numbers from 1 squared to 2 squared all the way through to 12 squared, and none of them will reduce to 5 mod 13. Yeah, okay, that's what this just told us, and that was a pretty efficient way to find that out, right? Okay, cool. Now, in preparation for this video, I wanted to see, how to pick my examples. So I wanted to do 5 over 29, and that became a pretty hard task, because while I was able to figure out what 5 to the 6 was relatively quickly by hand, notice that if we tried to figure out what 5 over 29 is instead of 5 over 13, on the right hand side we'd have to figure out what 5 to the power of 29 minus 1 divided by 2 is, and that's 5 to the 14th power. And 5 to the 14th is a lot harder to get to than 5 to the 6th. So you see that, if either A or P got too big, it becomes impractical to use Euler's criterion to calculate the Legendre symbol. Lucky for us, there are properties of the Legendre symbol that we can use together with Euler's criterion. So in future videos, I'll show you how to calculate the Legendre symbol even when A and P are both really big. Yeah? Alright, cool. I hope you learned a lot from this, and keep watching. Take care.